Hi, welcome back to Math 533, Topics in Euclidean Geometry. And this is our last video. This is going to be a quick recap of what we've done this semester. We'll talk about all the various things that we've studied and maybe draw a few pictures of the corresponding topics to sort of jog your memory. Our first module this semester was on axiomatic systems. So if you remember, we talked about what an axiomatic system is with its undefined terms and some axiomatic systems where we talked a little bit about some non-standard geometries to set the groundwork for why we have to specify what geometry we're working in. And then we talked about axiomatic systems for Euclidean geometry and looked at triangle congruences, the parallel postulate of Euclidean geometry and its consequences, notably the converse to the alternate interior angles theorem coming out of that, and also the angle sum of a Euclidean triangle. And we looked at how these ingredients fit together for solving some problems. So for instance, one of my favorite things that we saw was the pointwise characterization of the perpendicular bisector. Our second module was on transformations. So we talked about transformations of the plane. We talked about isometries. We talked specifically about reflections and how reflections allow you to build all of the isometries. Right? Every isometry can be written as a composition of up to 3 reflections. We saw that isometries characterize congruence of triangles. And we looked at other examples. We looked at rotations, we looked at translations, and we looked at glide reflections. And those we described in terms of reflections and proved various properties about them. Finally now, in our third part of the course, we looked at similarity. And I want to emphasize similarity is fundamentally a Euclidean property. And we saw the definition in terms of similarity transformations. We saw the various similarity theorems that we had, notably the basic proportionality theorem, which we attributed to Thales of Miletus. We also talked about things like the angle-angle-angle similarity theorem, the side-side-side similarity theorem. Right? So those are closely related to both to the definition and to this theorem of Thales. And then we also looked at the Pythagorean theorem coming out of similar triangles. Actually, we did it a couple different ways. And we also talked about the special points in a triangle, notably the circumcenter, where all 3 perpendicular bisectors are concurrent. We saw the orthocenter, the point of concurrence of the 3 altitudes. And we saw the centroid, which is the point of concurrence of the 3 medians. And then finally, this week, we've talked about how area scales under similarity transformations. And that's what we've done this semester. There are obviously many other topics. Notably, I think the most famous thing that we have not talked about this semester is the so-called Euler line, which is the fact that the centroid, orthocenter, and circumcenter are actually collinear in any triangle. So there are many of these centers of a triangle that people have looked at and interesting properties of them. That's maybe for another time or your own independent reading if you're interested in it. Okay, that's it for this video, and that's it for Math 533. Good studying for the final exam. We'll obviously be in touch as necessary, but this is the last video. Thank you for being along on this ride. Happy mathing.